Look, I'm just a geologist. I like rocks. I love rocks.
Go ahead.
Yeah.
Let's roll.
All right.
Start us off, Steve.
Good evening, everybody. Good morning. Welcome to the Geology Flannelcast. My name's Steve.
What's up? I'm Chris.
I'm Jesse.
And today we have with us two special guests. We have Chris Conwell of The Ohio State University. And for those who are friends of the show, we have Ryan Thornburg, who has been the thorn in Jesse's side for quite a few years now, talking about the summer of 1992. So we will jump into that in a second, but first we have to pay some bills and thank our sponsor, the Formatting Formula. Again, we talk about this every week, and every week I can't stress it enough. Like if you're ever doing a Word document of any type, the dissertation, even if you're just like trying to create a form or something like that, you need to watch the Formatting Formula videos on YouTube. There are literally like hundreds of videos for Mac, PC. I forget. Every week I say a different version of Word. One day I'm going to actually look up all the different versions of Word and say them in some sort of cohesive list instead of just saying Word 12. So, which I don't think is a thing. So, you know, anything from like table of contents, headers, footers, embedding figures, things like that. You got to go to youtube.com/c/formatting formula. And they have every kind of video you're going to need to do anything, you pretty much anything. And even if you come across some super weird thing that only you need, you can contact the Formatting Formula and they will figure it out. They know it. They can come up with custom like toolbars and all kinds of crazy stuff. So you won't regret it. Check them out. But when you check them out, make sure you tell them that we sent you. We want to look like the boss here. So even though they're paying our bills. So youtube.com/c/formatting formula for any of your Word document needs.
Well, all right. So we got an action-packed episode. This is going to be good today. So let's should we just jump right? What are we doing again? How are we working this out?
We are going to
literally just said this 5 minutes ago and I forget already.
Mano y mano, brother y brother, 1992
Battle Royale
swimming challenge.
I've got some data here.
Oh, they should be good.
I've got data. So in 1991, the Mount Pinatubo erupted. Mount Pinatubo, when did it erupted? Oh, in June of 1991, June 12th. In July of that year, in Pennsylvania, in Philadelphia, where I'm finding the weather data. So we grew up like 2 hours north of Philadelphia. So it was a little cooler to begin with. Check one in my favor.
There should be a weather station in Scranton.
Yeah.
There's one in Hamburg.
I had to do this real quick. I did it since we hit record. So
I got the tally going on my dry erase board right now.
In July of 1990,
Jesse's got 1 point right now.
In July, thank you. In July of 1991, there were 12 days over 90 degrees. We would go swimming. We'd walk up to Ivyside. It was great. In 1992, when the climate effects had taken a hold, global temperatures dropped a degree. There were only 3 days above 90. So we only go swimming when it's above 90.
Yeah, I was like, first off, take that point off. So based off of his facts that 1 degree difference, you're telling me as a 8, 9, 10, 11-year-old, it went from 89 to 88, and we were like, nope, we're not going swimming this summer.
Waiting for Ryan.
Now, was it 1 degree Fahrenheit or 1 degree centigrade?
1 degree Kelvin.
We do American units here.
Kelvin.
Kelvin.
America.
I'm gonna find the actual. I'm gonna find photo evidence of just us dry.
Of what? Not swimming?
Just dry brothers. It's like a 4th of July picnic. It's Christmas photos.
I don't know why you're doubting my memory from 28 years
I mean,
ago.
it's just ludicrous to say that if it goes down a degree, we stop swimming as kids when all we would do is it sunny out? Let's go swimming.
Mm-hmm. I mean,
It didn't even have to be sunny. It was summer. Mom just shipped us off to the pool. We didn't have an option.
my memory as a 10-year-old is pretty good, though. So,
And I was always like the first one to get cold and get out of the water. So I'd probably be more likely to not want to go to the pool.
Oh, point for Ryan.
Ooh.
And I still have no recollection of ever being like, man, remember that freezing cold summer when it was 88 degrees on average, not 89?
I don't know why you're stealing my memories like this. This is the summer of Jesse is being ruined in front of everyone here.
I do believe there was a promise made 2 episodes ago that all Patreon sponsors, Jesse will say whatever we request.
Oh.
That's the only reason I'm on here.
Yeah.
So for those of you who are just tuning in, Ryan is a Patreon, and Ryan is one of our apparently more wealthy Patreons, which we encourage and absolutely love his support. But yeah, that's true. You can get Jesse to say what you would like him to say right now, Ryan.
Did you guys send him my request?
Oh, he saw the request.
He got the text.
He got the text. There was you put that in, and within seconds I saw that.
I was so upset. I didn't listen to I missed you guys doing the live record last week. I would have loved to have joined that.
Well,
I also don't want to hold up any more time because you guys have had good guests. I don't know if Chris is gonna keep that streak going or not.
We'll throwing down the gauntlet.
Oh, wow.
Pressure.
I'll give Ryan another point for that one.
Maybe Ryan should just stay on. We'll just keep him on the whole show.
This is what I'm working with here.
Wow.
Oh, okay.
Hating over here.
And I just want to point out that I'm contractually obligated through Patreon to say this. At no point in my life did I go swimming less because of volcanic eruption.
And
Hey,
Ryan has 4 points.
It's still recording. I feel good.
To be fair, when you think about all the change we've seen from modern warming, that's only been from about a degree Celsius of change or so, right? So back in 1991, a degree Kelvin of change, or just 1 Kelvin, maybe it could have affected something more than Jesse's 10-year-old self would remember.
Thank you. That's all.
Despite Jesse's excellent 10-year-old memory, which I do not doubt.
I mean,
I have issues with it.
yeah, but Chris, Ryan pays our bills, so we have to keep him happy.
All right. Well, in that case, sorry, Jesse.
dang.
You might have taught one of the classes that I took, but that wasn't enough.
I'll still continue to call it the year without a summer of swimming.
Now we just didn't even have a summer. We just had no fun.
We had to stay inside. We were burning furniture. It was.
Oh, jeez. We used to have an elevator made of mahogany. We broke it apart to stay warm. Yeah.
I'm glad I wasn't alive yet.
Oh boy.
Oh, that's.
Jeez.
Hope that makes you feel good.
Oh, well.
No.
Well, Jesse, has Ryan's comments made you change your position on this summer of no swimming at all? No.
I'm gonna dig into this data. I'm gonna find a weather station in Pottsville.
You're gonna have to find the pool records.
I'm gonna find the diligent person who worked the door who would just let anyone walk by, not paying attention at all.
I'm sure there's meticulous digitized records of who walked in, and
I'm gonna try and find the receipts of the pierogies I got from the concession stand.
Your staff from that year is less.
Yeah, my pierogi budget was much lower that year.
You went to a pool that sold pierogies?
$1 would get you 3.
Yeah.
Wow.
Yeah, deep fried.
How about
pretty
that?
nice.
I'm pretty sure every pool in Schuylkill County sells pierogies.
Yeah, you said that like it's uncommon.
I've never been to a pool that sold pierogies before.
I don't even believe you've been to a pool.
Never been to a real pool, apparently. I don't know. Wow.
yeah, I think my pool only sold like soft pretzels and gum. Like that sounds awesome.
Maybe we get pizza. Maybe I don't remember. French fries, definitely French fries. I don't know.
I couldn't afford French fries. They were like $2. Yeah. Anyway, all right. Well, Ryan, we won't hold you up any longer, but thank you for this.
Thank you
Chris,
for this. This is
Seminac,
the most
what is
downloaded episode I have.
what is the point total so far?
The official tally is Ryan 4 points and Jesse 1 point.
All right.
Oh, well, we'll see. Who
We'll
wins?
we'll continue this debate on. We're not saying it's over now, but it.
No.
you know.
No. There's no debate. We can play back the tape. You said it.
I did.
That is true. Now, if you come on again, Ryan, just be like, "I'm sorry. Can we go back to the tape? What did Jesse say? At no point in my life did I not go swimming because of a volcanic eruption."
Maybe I should change the theme song at the beginning to just Jesse saying that statement. And then,
I mean, he does need. Isn't he still looking for Jesse's Corner music?
we're still, yeah. I mean,
Oh,
that's it right there. I could you have some music with him just kind of him
we'll like
going in and out
auto
of that
tune it or
statement.
something.
Yeah. Auto tune it.
Oh, that is perfect.
I get nothing but COVID time right now, so
Best
it's
money I've ever spent.
Nice. But seriously, Ryan, thank you for
Yeah.
being a listener.
Thanks,
thank
man.
you for
This is great.
contributing. Thank you for being on Patreon.
Yeah,
Thank
really
you guys
appreciate
for
it.
having me.
it's great.
And keep up the good work. The last few have been particularly good.
oh, thanks a lot.
Yeah.
Appreciate it.
You've
a
got
lot.
some great
Yeah.
guests. That's what I was saying. Like I've really been, as a non-geologist, you keep it interesting for me.
Nice.
Thank you.
Well,
All right,
thank
man.
you very much for listening.
No
Thanks.
Come on the
And-
show whenever you want. Whenever you find new information too, or new evidence about this
yeah.
summer
please.
without the pool, let
All
us
I do
know.
is I listen to these episodes and I just write down what my brother said that I think are factually incorrect.
You think he's joking, but
I know he's not joking at all.
I have spreadsheets.
Oh,
All right.
fantastic.
We'll run the statistics on those. All right.
Yeah.
Thanks again for having me. I'm going to sign off now.
All right.
All right.
Man. Thanks,
Thanks,
a lot,
man.
man. Take
All
care.
right. We'll see you.
Bye.
All right.
All right. Well, there you go. This
Now
is
that
Now
we
that
got
he's
the,
gone, let me
that roy-
rebut.
you turned that into a climate change podcast right there, real
Yeah.
fast, huh?
Mhm.
But that is a good segue for our actual guest, Chris Conwell of The Ohio State University.
Howdy.
Howdy, Chris. So, Chris, you're getting your Ph.D., is that correct?
That's right. Well, that's what I signed up for anyway.
So tell us a tiny, give me the elevator pitch of what your research is and pretend I'm a third grader.
Sure. So I study the changes in Earth system processes, basically what the Earth was doing a really long time ago that caused climate to change. And when I say a really long time ago, I'm talking about hundreds of millions of years ago. So if a listener has been following studies of climate change, they've probably heard about things like the ice record and how we study gases trapped in ice bubbles and things. I'm studying way back before we have ice. So I study rocks, but similar concept. Climate was doing something, we don't understand what it was doing, and so I'm basically doing forensics on rocks to try to figure out, try to unravel the story that's preserved there.
Cool. And
Where were you on the night of Tuesday, 485 million years ago?
Well, Chris, you bring up a good point. That's I try to tell students this a lot. It's like geologists we're like detectives. You talked about like you're doing like forensic work,
Yes.
and
Yeah.
that's it's almost like we have a crime scene. And I always tell them like there's that show Dexter, and like Dexter was the guy
Sure.
that looked at the blood splatters or whatever to figure out how the murders happened or whatever.
Wasn't he also a mass murderer?
Yeah, let's keep that's out. We're not talking about
That's details.
I mean, you could have went with CSI.
Yeah,
Uh,
A very popular show that was on for
3
like, yeah. No, you went with Dexter, the one where the guy's a serial killer. Carry on.
I can relate
No.
better.
Or like it's the equivalent of like reverse engineering the rocks. You know, it's like we got these rocks, and how did they get this way? You know, that's what geologists do. We're reverse engineering. How you know? Anyways, that's what geologists are trying to do with the rocks.
I one time, I think I said it to my advisor at the time. I was like, "We're like deep time detectives," and he was not impressed with that analogy.
He might have been jaded. But it's true. It's true.
Yeah, I think about it. The analogy I always use when I do my set environments class, especially, is like the layers of the rocks are like pages in the book. And you have all these pages torn out, and you're trying to piece together what the plot was or what the chapter.
That's right. That's right. Something happened. There's there is a right answer. Something happened, and we have 20 ideas of what it is, but one of them, or maybe none of them, is right. But we're trying to figure out which one it was.
Yeah,
well, I think you just found that's your conclusion section for your dissertation right there. Right?
Yeah, pretty much.
That's I know.
I've been riding that wave for as long as I can. So.
But that's part of what you do in science, right? You're coming up with an explanation, and if someone proves it wrong, that's actually a good thing, because then it narrows it down further.
Yeah, we can discuss this a little further when we get into Jesse's corner, because some people you would think like, hey, that's great, you came up with a reason why I'm wrong. Like, that's fantastic that you came up with new science. Other people are like, I'm going to punch you in the face because you're wrong. Because I said this and you say I'm wrong, then you're wrong.
Yeah.
Like, and
destroy your career.
Yeah. So, speaking of segues, should we jump into Jesse's corner real quick?
Yeah, I guess. Yeah.
I'm sorry.
I've never heard.
Hang on.
I've never heard Thornburg sound so like sure of something in his life. Right there. It's not like he knows this is coming. Like
literally. Yeah, that sums up my existence of my certainty in life. Okay,
I'm with you, Jesse.
Yeah, I wasn't sure if you bringing my brother on to ambush me. It was an ambush. Counted or not?
That text exchange happened on like Friday. It is now Monday evening on the 29th of June.
We're in a group chat and on via text message, and I could just, as soon as I sent that text to these guys, to Jesse and Steve, I could just tell, like, from Steve's response, that his eyes lit up like it was Christmas morning. He was 5 years old, and it was Christmas morning. He's like, yes, we have to get Jesse's brother on about this.
and Jesse, to your detriment, I think I was like 3 beers deep too. So I was like, oh, this is happening.
But
okay, I'll do. Chris, you're going to do the dinosaur story, right?
Yeah.
All right. So I'll do two real quick ones here. One is Steve sent me the story, so I'm going to give a little hat tip to him. It's about this small time miner in Tanzania who found
Tanzania? Is it Tanzania?
Tanzania. What did I? Sorry. Yeah, Tanzania. Yeah. Sorry, Tanzania. And he found two really large Tanzanite stones worth $3.3 million.
Jeez.
I was actually
Tanzanite,
which is really funny because I was just reading about Tanzanite. So Tanzanite is one of these really funny stones where, like, you can get it. They sell it a lot, like, in travel shops. Like, if you're the story I was reading, I've never been on a cruise, so I don't but apparently they sell it a lot on cruises, and they're always like, this is a very rare stone, it's a good investment, and they make like jewelry out of it. It's a gemstone. And one of the things about it is that, like, in reality, it really is pretty remarkable in that you basically only find it in Tanzania.
Tanzania.
I usually pride myself on my geography too. And like, it is fairly, like, it's more restricted in where you find it compared to, say, like diamonds, but the markets are just different, so it's cheaper. But this is a really cool.
I just learned that it was given the name Tanzanite by Tiffany Company.
Oh.
You know Tiffany. It was named Tanzanite by Tiffany, which is hilarious.
Yeah.
And here we are using it anyway.
Yeah, so it he found it. So Tanzanite, if you don't know, it's like a violet blue. It's pretty.
It's pretty, yeah.
Yeah, I'm looking at it right now. It's really pretty.
And if you see the rocks, they're like I don't know, like 2 loaves of bread. Like that's how big they are. Like they're huge.
You're talking about the ore? Wow.
Yeah.
I mean, they were like they look like
funny.
faceted crystals. Like they had faces on them and stuff. I mean, they looked all dirty and everything, but
20.5 pounds.
Yeah, wow. I'm looking at the picture right now. Holy
shit.
crap.
20.5 was the one, and 11.5 was the other.
Wow.
So he said he's gonna throw a big party, and
He should. He absolutely should.
Yeah, he's gonna build a school, and he's gonna continue to look after his.
He's got 30 kids.
He's got 2,000 cows.
Oh my God! You can buy a ring of Tanzanite mounted in platinum for $10,500.
Wow. I mean, you can. I can.
Yeah.
One can. I don't know.
I can after 20 years of easy payments.
So if you want to support the show in our Tanzanite dream, go to Patreon.
Yeah, I'll get my ears pierced. You know.
Yeah, I can't. People are like, "What are you using it for your servers or to upgrade your equipment?" And we have like Tanzanite. Like, sure, servers.
Yes,
servers made of Tanzanite.
Oh man.
So I thought that was a pretty cool story. It always reminds me of the one story about the small time miner who had the raw uncut diamond he was using as like a doorstop. He didn't realize what it was. And it might be apocryphal, this story, but like an unscrupulous guy came in and realized and was like, "I'll give you $20 for that doorstop."
Oh no!
And it was a $200 million diamond or something insane. I'm not sure. Don't fact check me on that one.
No, but there is the Field of Diamonds story that are.
Yeah,
I'm sure it's happened. Yeah.
The university where we all went at some point in our lives, Temple University, and Russell Conwell, and his Field of Diamonds story.
Famous.
Oh, that's right.
All right. So the last story, and this will segue into Chris's story here. So, I've actually heard this story before, but it looks like there's a new study out about it. So the End-Permian Extinction, 252 million years ago, largest mass extinction, killed off 95% of all life in the ocean and 70-80% of all life on land. And there's some unknowns about the trigger for it, or the mechanism. And one of the things people have always looked at were these big flood basalts that were occurring at the time, the Siberian traps, they're called. So massive amounts of basalt just flooding onto the surface. One of the thoughts now is that when they were coming up, when they were bubbling up to the surface, they were actually coming through large layers of coal and organic material. So as they're coming up, they're combusting just all of this coal, square kilometers of coal veins. And so it's adding to all of these halocarbons and CO2 and just sulfur, because it's pretty low grade coal. So you put all the sulfur up there, you get acid rain, which messes up the pH of the oceans. So kind of interesting. It was I can link to the article. It was published. It was a research article that came out last week in Geology. It was a fairly reputable journal. So,
a little bit, I'd say. Fairly.
So End-Permian was what? How many?
250.
Yeah.
All right. So 252 million years. So I guess they see these basalts And then what? Next to them are coal beds? Like, how do they know it went through coal? Or are they just modeling it and figuring out?
No, it's field evidence.
That's really awesome.
Yeah, combusted in these.
Did you post it? You have the link to that? Would you post it in the chat?
I would totally do that.
Because I missed this paper.
I'm happy you're interested. That's all I look for in Jesse. I want to have you on every week.
You were the first guest. Yeah, Chris, you're the first guest that's ever asked that question. Can I see this article? It's really interesting.
Yeah. So, apparently, like there's a river valley where you can see the basalts and like just miles of basalts, and then you see combusted material.
Wow.
You see a big carbon isotope excursion.
Sure. Yeah. Well, yeah. I mean, that should be pretty telling because, right, if you're liberating a lot of carbon from coal seams, that should have a really distinct carbon isotope signature relative to what was in the oceans at the time. Because I know that coal is super light, super distinct.
Yeah.
From everything else.
Yeah, it's pretty crazy. Oh man, they have some pretty cross-section pictures.
Neat. So I always had an issue with the End-Permian. What would kill more?
Really grind your gears.
Yeah, don't hold back, Peterson. Right?
They always tout this stat of 95% of life died in the oceans, but only 78%, 80%.
Yeah.
Died on land. Like
that's still no number to,
No, but that's a 15% difference. Like what is going on that would kill the oceans more than stuff on land? I could see it the other way around.
I think
the ocean chemistry changes.
Yeah, life in the ocean is much more like they're much more specialized. Where if you
like
tweak the
subtle
salinity,
changes are really like look at like what's going on now, like with the ocean bleaching and like coral dying and things like that. Like, it's as of right now. I mean, I guess people. I don't even want to say it. Never mind. I know people just jumped down my throat for saying what I wanted to say, but
I can't wait to ask you.
Me too.
Yeah, right. Subscribe to Patreon because we're going to be talking about this after this.
Yeah. You want to get the extra content.
Yeah.
Well, I mean, on land, at least in the modern, when latitudinal climate bands move, habitats move with them. In the ocean, if you're a coral, you're out of luck,
Yeah, I guess you're right. Yeah.
Yeah, and these are all.
You've changed my mind. I'm good now.
All right, never mind then. I was going to say, we're just estimating anyhow.
Right. Yeah. No, I know this is, hundreds of millions of years.
That's what we do.
Yeah.
Like we had this much. Now we can only find this much. So that must mean,
this is.
I'm doing a Ph.D. in estimating. So.
Well, the other thing is like when geologists come up and paleontologists come up with these numbers about like, X percentage of life died off from a mass extinction. I never really understood, like, I guess I know the basics on how they come up with those numbers, but I mean, you're dealing so obviously the further back in time you go, the more coarse resolution data you're going to get.
Yeah.
And, we know that fossilization is kind of more the rarity. Things don't, it's very rare when organisms.
It's the exception, not the rule.
Yes. Thank you. So there's all these different variables too. And it's freaking hard. It's really hard to do this stuff is what I'm trying to say.
Say as like a general, like rule, not a rule, but a general like thought, like if you come upon a number like that, where you're like 90%, and like you always hear that, you say like, how many things died? 90% in the ocean. Try and find out where that number comes from.
Yes.
Last 2 years ago, we were writing up something, and I put in a number. We can talk about this later. It gets a little technical, but I put in an isotope number for what I thought the ocean was in the mid-Cretaceous. And I remember an author was like, no, you can't use that. You got to use -1.2. And I was like, why? And it's like, that's just
I remember
number.
this. Yeah.
And I was like, all right. And I remember like going to, and it's the number everyone cites. It's just the number.
Yeah.
Why?
Going to the source, and it says nothing about the Cretaceous. It says nothing about any of this. And I remember going to a geochemist in our department and being like, if I asked you what the value was, it's like 1.2. I was like,
You're talking about G. Are you talking about G?
Yeah. And I remember like, I was like, I went to the original Shackleton paper and it says nothing about the Cretaceous. And he looked at it, he's like, huh.
I can picture the look on his face.
Well, that happens a lot more in science than, like, I've had experiences with that too, where people just kind of take for granted something that, like so-and-so paper said this. And when you really, really dive down and you analyze every single sentence in that paper, you're like, where the F is this thing coming from? Like, what is this? Like, this is...
like if I were to ask you, how many glasses of water are you supposed to drink in a day? What would you say?
8?
Isn't it 8? Yeah, that's what I thought.
Yeah,
8.
right.
So that number has been cited in so many medical journals and so many papers over the years, but you trace it all the way back. It was like one doctor in like the 40s or the 50s who like said, like, you should really drink 8 glasses of water a day.
Yeah, that sounds
and
right.
it was like based on no research, no foundation, just like, and don't get me wrong, it's I'm sure it's not way off. Otherwise, somebody would have called BS on that a while ago.
Yeah.
But like, you all said 8 glasses of water, and that's what I was taught too. Like, you need to have 8 glasses of water in a day. And it turns out like sometimes you need a lot more. Like if you're in, the blazing hell that is Atlanta right now.
If you happen to be training for a 30K race in Atlanta in the summertime, maybe
true.
you have to.
So, or,
inside joke. I'm sorry.
No, but if you're in somewhere in a climate where it's hotter, you're going to need to drink more water. But if you're, sitting in your home in Philly in January, maybe you don't really need 8.
I got a great quote by my favorite patriot, Benjamin Franklin. It is the first responsibility of every citizen to question authority. And I think that's science in general. I mean, like, science as scientists.
Jesse, can you mute Chris?
What? For quoting Ben Franklin? Like, that's a kick-ass quote right there. Like,
you're out of line. You're out of line, sir.
How dare you?
No, but like as scientists, I always try to tell my students, like, listen, as scientists, like, your BS meter should be on high. Like, anybody can say whatever kind of like ridiculous statement they want, but as a scientist, you're there to think critically and is this BS or is there, substance behind this?
It's a balance between like thinking critically or whatever and being like always being a contrarian.
Well,
so like, I agree with you. You should always
not supposed to take anything for granted. Which is a perfect phrase for a geology podcast.
Yeah, don't just question authority. Challenge it.
But it is okay to like stand on the shoulders of giants. I'm not saying you have to redo every single experiment
2 + 2 doesn't equal 4.
Right.
But there's certain things like you got as a scientist, you have to like I said, have your BS meter on high and just be like, does this sound right? That sounds a little fishy right now. And, there's always like things like that in science.
And that's why I think we like,
but it's great because science is all about debating. And this is like a perfect arena to debate ideas.
But we published the steps we took. So if someone did want to reproduce it, because it should be reproducible.
Yes.
Yes. But we also had this conversation.
Yeah, this is just like 2 podcasts ago, right? We talked about reproducibility in geologic research.
Yeah, it's tough.
I understand sometimes, though, going back to the 8 cups a day of water thing, it's like sometimes maybe it's 9 cups or 10 cups, depending on where you are. But you know what? 8 cups is good enough. Someone said that, and I can put that in my scientific publication or whatever, and no one will question it.
Well, that's the problem.
And it's not, it's you're right. We're limited by the system because as much as we're all trying to meet our ideal selves as scientists, we're also trying to keep our job, Mm-hmm. So it's like, we're stuck with that.
Yeah, it's just one of those things where I don't know. I think as scientists, like Jesse's had an issue with this. Like, why do we use this? Well, I don't know, because so and so said this. And it's kind of like it gets like, I'm not saying that the peer review process is perfect. It's not.
Oh, it's far from it. Yeah.
It's pretty good. It's pretty good.
Yeah, it's about the best. It's about the best we've got, but it's far from perfect. Yeah.
Yes. Yeah. So I mean, like, nothing in humanity is flawless. But and I've come across things in my own personal research where it's just like, well, I've always been taught, like, this, it comes from this paper, and then you read that paper and you're like, they never really said it. So
Yeah.
I guess I don't want to, keep on, drawing out this topic, but, it's always, always double check your facts. And I guess, I don't know, always question authority. There you go.
Don't be afraid to question.
Yeah.
Your
That's what the scientific process is. It's just you question. Who is it? Descartes said, "I think, therefore I am." Right?
Look at you, just pulling out these quotes.
Oh,
You're bringing the big guns this week. Really.
And if the person in question is a good scientist, they'll understand where you're coming from.
From my experience, it's the ones that always get like a little like wishy-washy. Like they get all. I'm not wishy-washy. I should say like defensive.
Sure. Yeah.
Because
right.
As scientists, I'm an academic. I do research. Research is part of my career, and with any research paper you publish or any research talk you give or whatever, what the your weak spots are. What's a better word for like the areas where people can kind of punch holes in.
Exactly.
Every research project.
I've never had any holes in any of my research projects.
And you are the person that I'm most nervous about. No, if you ever say there's no weaknesses in my research, then something clearly went wrong. Maybe not all the time. I don't know, but
no, I understand what you're saying. Yes, that absolutely makes sense.
But I've noticed that the people that get the most defensive are the ones that know that there's some holes in their research, and that's why they get defensive. Because if you're sure about it, it's just like, all right, cool. Like, there's, I can talk, I can explain this. But anyways, sure. I think we're kind of
spiraling,
moving away from the topic a bit. But all right. Anyone else have anything to say about this topic? This is a very heated topic. Got us talking a little bit.
I think it's always good to talk about.
Yeah,
it is.
Especially remind our listeners who maybe are just starting out or getting into research. Like, part of doing research is questioning. That's trying to answer questions. That's what we're doing.
There's nothing wrong with questioning. That's it. That's actually a good thing. If you're a scientist, it's a good thing to question.
I love having these conversations with non-scientists because I think it shows it's useful because how many people know personally a scientist? Like, most people don't. Most people you talk to on the street couldn't name a scientist.
I know.
So I think, but I think I like having these because it's a chance for non-scientists to see how science actually works and how much gray area there actually is. And not that we're making stuff up, you understand, but we're doing our best. Yeah.
Especially if you're a non-scientist, you should always question a headline.
Please.
That's where it comes in. You read these like this. What are they called? Clickbait articles. And
it's the worst.
Like, what a bunch of garbage. Yeah. How many times have you clicked on a clickbait article and you're like, you read like the first paragraph, you're like, come on,
and they make you click through like 50 more until you finally get to the point where you're like, really? I just need that one sentence. That's awful.
Yeah. So, all right, let's. Just you got another another article, or are we going to talk about this?
I'm all out. I got one or two. I'll save them for next week because
this went a little long.
Yeah, I've got one that's longer too. It'd be interesting to talk about.
Mm-hmm. Okay. So Do you want me to talk about this
Yeah,
article, or do you want to just go into Chris's stuff right now?
Let's just go. What do you think? Going to Chris's stuff. We've been running long here.
Yeah, we've been running long. Let's go into Chris's stuff. Yeah.
He's the reason we're here.
Sure.
Yeah.
man.
All right. Well, we'll talk about this. We got some other episodes coming up later. All right. So, Chris, let's talk some more about your research. All right.
Sure. Yeah.
So, okay. So, you're a PhD. Are you your candidate?
Yep. Candidate. Yep.
Nice.
Nice. Congratulations.
Yeah.
Thank you.
An interesting time.
Yeah.
For candidate.
For anyone that's listening, basically about halfway through your PhD, you're subject to a rigorous assessment of your ability to be a scientist. and that it's as uncomfortable as it sounds. But once they call you a candidate, that means you pass. So I passed. And
it's about as much fun as like getting like beaten by a hose.
Yeah. I was fortunate. I had a pretty good, and I'm not just saying this because I'm on the record. I had a pretty good committee, so it was all right for me. But yeah, I'm thankful that it's in the past.
I like once you become a candidate too, you're all but dissertation, which makes it sound like, oh, I just got to write it up. I'm all done.
It's going to write like a several hundred-page book right now.
Yeah.
Now, for someone who's never had to go through this process, how, on a scale of 1 to 10, how much more difficult was it than our comps for our master's degree that me, Jesse, and Chris all did? And I'm met with silence.
Well,
that I can't because I never did comps.
Answer?
My comps. I feel like when I had comps at Temple, they were still old school, and so they were tough. And I think Steve, you had the same.
Yeah, mine were hard.
Now they have. I don't want to get into that.
No, I understand. Now it's a little more like tested for more geared more towards like the PG or something like that.
Yeah, I mean, when we're starting to turn into like old heads here. We're like, well,
back in my day, I walked the hops in 10 feet of snow, and
like, I honestly remember like Dr. Meyer just handing me a rock and being like, what is this? Where did it come from? What's the geochemistry? Tell me. Like, it's just like, I got lucky.
It was definitely more old school. I agree. We went through more of an old school thing for our masters, and I think a lot of schools are going away from like a comprehensive exam for their masters.
My PhD was a lot more geared towards what I was actually researching, which it was it was still pretty rigorous. And I wouldn't do it again, no matter what you paid me. But I don't know. It might be apples to oranges.
I think it depends where you're at, who's on your committees and stuff.
Yeah, that's right. That's right. You hear some horror stories of people with pretty tough committee tough, not in a constructive sense. But I think for the majority of people, it's an uncomfortable experience, but it's almost for lack of a better word, a rite of passage, and then you do it and you're done, and that's it. So,
well, Chris, I guess I don't want to get too far off the point here, and because this is another like rabbit hole.
Yeah.
We have a whole other
Absolutely.
episode on just talking trash on things and whatever. Let's talk about your research. You're here.
Sure.
I want to talk about your research. This is some really cool stuff. So you're doing a lot of geochemical work.
That's right. Yeah, that's right.
So the cool thing about geology is like this, for the listeners that are, for the people that are listening that don't have a background in geology and just kind of, they like listening to this for fun. Geology is the science where it involves every other, it's like a conglomerate of science. It involves biology, physics, chemistry, mathematics, you name it. It's all of the sciences mixed together to figure out how the earth works.
But Seminac, everybody listens to this for fun.
Whatever. All right.
Sorry. Carry on.
Okay. So, Chris, you are interested in the Ordovician period, right?
That's right.
So we're dealing. So you're dealing with ice ages in the Ordovician period.
That's right. Yeah. So one in particular. Yeah. There's sort of so the Ordovician was from 485 million years ago. So for our listener, you probably heard some of these, but we break time up into, we name the slices of geologic time so we can know what we're talking about. So the Ordovician is one specific slice from about 485 million years ago to 444 million years ago. And so that's where I'm set for my PhD.
Right. So imagine it like calling it like, this is punk and this is new wave.
Exactly.
Is, alternative.
The 80s and the 90s. Yeah, exactly.
I thought about it like that. But now I'm going to think about the Ordovician. What would the Ordovician be?
Big band.
Big band.
The Ordovician, yeah, exactly. The Ordovician would be the whatever, yeah.
The Sinatra, the Rat Pack, all that.
Yeah.
Yeah, so, there's that classic geology cartoon. Name the 3 types of rock.
Oh, yeah.
Yeah. Punk, classic, and hard.
Yeah. Okay. So what are you looking at, Chris? What's explain yourself.
Yeah, sure. Yeah. Yeah, put me on the soapbox.
Yeah.
So what I do is I sort of said this at the beginning. There's stuff going on with climate. So Chris Seminack kind of alluded to this with talking about an ice age. So basically during the Ordovician, over a period of about 40 million years of Earth's history, we know pretty well from the last century of research that there was a dramatic global cooling during this time. When I say dramatic, I'm talking about on the order of 15 degrees Celsius of sea surface temperature cooling. And to put that in perspective, I also mentioned this earlier in the podcast. If you think about the last 200 years, all the profound change to Earth systems, like the biological system and the oceans and whatever, that we've seen in the last 200 years or so since the Industrial Revolution, that was all caused by about 1 degree Celsius of change.
Yeah, so imagine your whole life you lived in Miami. Yeah. And then all of a sudden you lived in northern Alaska.
Exactly.
Yeah. 15 degrees Celsius, just for our American listeners, is 59 degrees Fahrenheit.
And even for another point of reference to scale this climate, the last ice age, the last major glaciation was like 5 to 6 degrees Celsius. And that's
exactly.
And that was about 20,000 years ago. Yeah,
exactly.
Ice over New York.
And so it's a little bit different because we're talking about a 15 degrees Celsius change over 40 million years. Rather than a 5 to 6 degrees Celsius change over 20,000 years. But still, it's not necessarily, I mean, that is an open question. Like Chris Seminack has referenced, it's the further back you get in time, the harder it is to figure out what happened. So
I always like to say, it's like, if someone asked you like, hey, what'd you have for lunch yesterday? You could be like, oh, whatever. I had a ham and cheese sandwich,
Sure.
But if somebody asks you, hey, what did you have for lunch 2 years ago? Like, dude, come on. I don't know. Yeah. Like, it's you don't remember. You might remember like 1 or 2 awesome meals. Maybe you went out for dinner on your birthday or something like that. Good. But that's kind of what geologic time is like. So something that's like hundreds of millions of years ago, you're like, dude, the resolution is so coarse. So you're not getting this So that's why, like, the more recent stuff, like the more recent ice ages that we've experienced, we can say, like, this is on the order of like 100,000 years or something like that, because we have that kind of resolution.
Yeah,
that's right.
I sometimes show, if you can look at either an isotope curve or like a sea level curve for the past million years versus the past 100 million years, and you can see how much more detailed the past million.
Oh yeah.
So much more evidence and resolution.
But I will say this, I will make a plug for the early Paleozoic 480-ish million years ago. We do have some pretty robust data sets available. And in fairness, they might take more work to get, is the thing. So, you know, in my PhD, I mean, so far I'm about 3 years in, and I've made about 60 data points. And that is through this interval of time. So, you know, 60 data points, I mean, for a non-scientific listener, that the point is that's not that. If you look at records from 20,000 years ago, they have hundreds of data points. I've made 60 data points in the last 3 years, but for my time interval, 470-ish million years ago, 60 data points in that interval is about, that's the densest that we've gotten yet. So I'm biased, but I do think this is exciting stuff.
Yeah.
So let's talk about your methods.
Sure.
Yeah. So what are you doing?
So I mentioned I'm trying to study drivers of climate. Like I said, we know that this dramatic cooling of about 15 degrees Celsius is pretty evident, and I'm sort of accepting that as fact. And that at this point is fair because there's been a lot of work.
A lot of
done.
information during the there's a lot of stuff is pointing to this.
Yeah.
The Earth is cooling down.
People have been studying that topic for decades. So it's clear that. But what's less clear is what the heck causes a 40 million year period of cooling.
That's a lot.
Is still a very open question. We have some ideas. So I am studying specific aspects of ocean chemistry. So basically, you know, if you want to understand, I mean, the oceans make up 70% of the Earth's surface area.
Sure.
So if you want to understand, and you know, that's in the modern, that hasn't changed a whole lot over the last 500 or so million years. So if you want to understand what the Earth was doing that long ago, you try to study ocean chemistry. There's a lot of information preserved there. So I study specific aspects of rocks, limestones. I mean, most people have probably heard of limestone. Mm-hmm. The limestones form in the oceans. And so if you want to study the oceans from 480 million years ago, the only thing that's left are the rocks that formed in the oceans. And in our case, it's limestone. At least in some places. That's what I'm interested in. So I study specific aspects of ocean chemistry from 480 to 440 million years ago that are preserved in limestones that formed in the oceans during that time.
Very cool.
So what? So you're looking at certain elements though.
That's right.
In these limestones, you want to go into a little more about that?
Yeah.
Well,
I guess
just real quick, like the ocean chemistry, basically gets locked into the rock.
Yeah, exactly.
It's like a snapshot of what the chemistry was, and then when the rock gets preserved and the rock turns to rock, it kind of like freezes that chemistry.
Well, it's a snapshot with a lot of asterisks.
Well, yes, but it
can change. It can change. Exactly. In the perfect scenario, it is an idealized snapshot of what you were looking at 480 million years ago. And of course, we have, and I won't get into it, but that's a whole rabbit hole in itself of ways to verify that what you're actually seeing in the rock is what was around 480 million years ago. Because exactly like what Chris said, sometimes you're looking at the chemistry of a rock, and a lot can happen to a rock over 480 million years.
It's buried, it gets heated.
It's messed up. Yeah.
Yeah.
But
sorry,
I like to think that we look at pristine limestones that perfectly preserve ocean chemistry.
It's basically a test tube from 480 million.
Yeah, exactly. You know.
All right. So specifically, you are looking at you analyze the elements of strontium and neodymium, right?
That's right. Okay. So
It's like, can you give the listeners just like a I guess try to give it like a watered down run through so that the basic person out there doesn't have a scientific background can understand why you look at strontium or you look at the element neodymium?
Absolutely. So, some background. So I mentioned that, all right, so tying it back to what I was saying, this cooling happened. We don't know why, but we have some ideas. One of the big ideas is that there was a certain type of rock, basalt, that was brought up to the surface. And basalt is special because when basalt dissolves, so any rock at the Earth's surface is in contact with, we call them surface waters, but rainwater, river water, whatever. So any kind of rock exposed at the surface is dissolving very slowly, but it's dissolving. And so when basalt dissolves, it removes CO2, carbon dioxide, from the atmosphere. And for the listener, don't worry too much right now about how that happens, but it does. So I am trying to test a hypothesis that during this time, during the Ordovician, where there was cooling, but we don't know why, we do also know that there was a mountain building event called the Taconic Orogeny, if you want to look it up. A mountain building event, the Taconic Orogeny, that we understand brought a lot of basalt up to the Earth's surface. And so all of a sudden, there was this big body of basalt that was dissolving and thereby probably removing CO2 from the atmosphere, which could have caused this cooling. This hypothesis has been around since about the 1980s because it's really hard to test. How the hell do you figure out if a body of basalt was dissolved 470 million years ago? It was dissolved. It's gone, So that's why I study. So I look at when I say specific aspects of ocean chemistry, strontium and neodymium isotopes. So if you don't know what an isotope is, it's not important. The point is that basalt. What?
It's like go Topes.
It's the Simpsons.
Go
reference.
Topes.
Don't listen to him.
Exactly.
He's just dumbing things down over there.
Hey, that's my whole purpose here, baby.
Well, okay, Chris. Okay,
Yeah.
Chris.
Stop
okay.
me. Yeah. Stop me.
So that was awesome. There's a lot of information there. So let's just break this down. Okay.
Yeah.
Number one. Okay. So you mentioned the Taconic Orogeny. Okay.
Sure.
So the term, and just in case there's any listeners out there that don't have a geologic background, the term orogeny means mountain building event. Okay. And so let's see. I guess this is a mountain building event that was seen on the east coast of the United States.
So
right.
Imagine what India, like the Himalayas, are now.
Well, and there's some thought that the part of the reason we're in an icehouse world now, and so whether, I don't know if you know it or not, because we have ice on Antarctica and Greenland, we're considered an ice house because there's ice masses, even though the world's warming up. Before that, prior to that, we were a greenhouse for a long time. In the Cretaceous, where the dinosaurs, it's a greenhouse, no real land mass ice. One of the thoughts of why we cooled, and we started cooling about 33 million years ago, that's when Antarctica started growing ice. One of the thoughts is the uplift of the Himalayas when the Indian plate collides with Eurasia. And so it uplifts all its material. And when you uplift all that rock, it starts to weather, and the weathering process draws CO2 out of the atmosphere.
That's right.
Interesting. You mean the Himalayas?
Himalayas.
But that also coincided with the Drake Passage opening. Am I way off?
There's like 5 different things.
Okay. I was going to say, I thought there was a little more.
The evolution of grass.
C4 grasses. But yeah, nobody wants to listen to that.
Let's go back in time. All right. Way before Everest was the biggest mountain on Earth.
No one cares.
Yeah.
No, but I'm just saying an orogeny is land masses smashing together, creating mountains. That's what I was trying to get at.
Yeah.
That's right, yeah.
What's Jesse holding up right now?
Geology, where subduction always leads to orogeny.
It was
That's
the
how I
shirt-
think about
it.
it.
Was the shirt I was literally wearing
Okay.
before
Nice.
I
Okay.
on my floor.
I remember being on a field trip and a student asking, like, so this is where the orogeny happened? And they're like, yeah. Like, so am I standing in the erogenous zone?
Kicked him off the
Gave,
field trip.
gave me a chuckle. Anyway, great. Semenek, you can note this down to
Edit this out.
This is going to be an editing nightmare. Thank you very much, Peterson. He's
Come on,
seasoned veteran
again,
over here, just
not
giggling and
really
me toiling
bad.
over this podcast.
Not really
Okay.
bad. Just
Let's get. I'm not editing it out. Okay. So, let's get. Okay. So this mountain building event called the Taconic Orogeny. This occurred on the east coast of the United States, essentially. During the Ordovician period. And what happened was there was a chain of volcanoes. We call it island. It's called an island arc of volcanoes. Think of like the modern day Japan off the coast of China. This is what was happening off of the east coast of the United States. There was a chain of volcanoes, of island volcanoes, essentially, off the east coast of the United States, and that chain of volcanoes smashed into the east coast of the United States. Obviously, it wasn't the United States back then, and that was the mountain building
America.
of America, and that was the mountain building event. Okay, and so this is seen in the Appalachian Mountains. There was actually, a lot of people don't realize this. There was 3 mountain building events that make up the Appalachian Mountains that we know of today, and this was like event number 1, you could say.
Yep.
So that happens. Okay. So now with all of this volcanic activity, you get a lot of lava flows involved, and that's where your basalt comes from, right? You mentioned that you're interested in the weathering down of the rock basalt. So we have these islands, these volcanic islands, they smash into North America, and now there's all these lava flows coming out. Now over time, the lava flows of this that they turn into this rock basalt. It's not stable at the surface of the earth, and it starts to chemically erode down. There's chemical weathering. There's chemical reactions that cause it to break down. Okay, so that's where you see you specifically you're saying that weathering down basically sucks up carbon dioxide.
That's
okay.
right.
So now the other thing. So we got the Taconic Orogeny explained. The other thing is, let's talk about carbon dioxide in the atmosphere. So the amount of carbon dioxide in the atmosphere can be a proxy for what your global temperatures are going to be like. So if you have a lot, carbon dioxide is a greenhouse gas, and that's the gas, like you'll hear a lot of people, when they talk about climate change, they're always talking about CO2, carbon dioxide. And that's because carbon dioxide is a greenhouse gas. Essentially, make a long story short, without going off into a lot of details, too late. It traps heat inside the earth, inside the atmosphere of the earth. So it warms things up. It's like, think of it as like a big comforter blanket wrapped around the earth. The more carbon dioxide you have, the thicker your blanket is.
Right. So think of a greenhouse. The greenhouse, the gas is the glass. It lets the light in, traps all the heat.
Yeah. Okay. So now we have, so I think that kind of sets the stage now, Chris, for you to take it to the next step. Okay. So
Sure.
Go ahead. Your turn.
This is what I need, because without people stopping me, I'll just blast anyone with a fire hose of.
No, it's just that you have such a cool story to tell, and I just want all the listeners to understand your super awesome story.
I'm glad you think so. So the fundamental question is how the heck can you detect, how can you reconstruct weathering of a big region of basalt, a region the size of the whole modern east coast of North America? How can you detect the chemical weathering, the dissolution of that much basaltic rock 470 million years ago? And so that's why this hypothesis has been around since the 80s, because we've been trying to figure this out and we haven't had a great way to test it. I'm not saying that I'm going to come in with a panacea and solve everyone's But I do have
This is the place to make bold statements, buddy.
Claim,
I gotta throw myself on the sword. So what I do is, I study, like Chris Semenak said earlier, so I look at specific aspects of ocean chemistry preserved in limestones during the Ordovician. I look at isotopes of strontium and neodymium. If you don't know what an isotope is, that's okay. The point is that strontium and neodymium are two elements on the periodic table. If you look it up, you'll find them. And there are different masses of strontium, and they're all strontium and they're all neodymium, but there's different. It's like a car and a truck. They're both automobiles, but they're different masses. And because they're different masses, they behave differently. If you try to drive a truck on a speed course, track, whatever, it's going to be different than if you were driving a sporty car, So strontium and neodymium.
That's very good.
Yeah.
I like that. Yeah. Yeah.
So
this is still a Toyota, and this is still a Honda, but they're different Toyotas and Hondas.
But they weigh differently, and that is important for how they behave.
Yeah.
So the point is that between basalt and other types of rock, basalt is sort of a rock that's usually found in the ocean rather than on the continents where we are. And so that's why when Chris Semenak said earlier, these islands of volcanoes out in the ocean, we call them volcanic island arcs. They're interesting because they're made of a lot of times a lot of basalt, or at least different rocks from the continents, more basalt-like, even if they're not actually basalt. So when one of these rocks smacks onto the continent, all of a sudden it brings up all of this basaltic type of rock, and that basaltic rock has different masses of strontium and neodymium from the rocks that are dissolving on the continent. So the point is that should appear, that change in strontium and neodymium masses, because it all goes into the oceans. All rivers, remember we talked about surface waters, rain, river water, whatever, they're dissolving rock that's exposed at the surface. That's all flowing into the ocean, more or less. So if a new type of rock is brought up to the surface, say basalt, and that rock has a distinct strontium and neodymium composition, isotopic mass composition, you should see that in the ocean chemistry 470 million years ago.
Okay, now my question is, why strontium, why neodymium? Like, what makes them the bee's knees when it comes to, there's what, 100 and this is gonna be
good.
Yeah,
sure,
128 elements on the periodic table that you can measure.
It's 122.
We'll get some.
That's a great question that I've never been asked.
118.
And so here are my thoughts.
118. Sugar snaps. I'm sorry.
Here are my thoughts. One is that rocks like basalt and rocks like what you find on the continents, like granite, most people have probably heard of granite.
Sometimes
they have,
you can take it for granted.
You can take it for granted, and I do.
This is what I'm here for.
They have very distinct compositions, isotopic compositions of strontium and neodymium. Sometimes you're looking at other types of isotopes, and the isotopes in a granite and the isotopes in a basalt are pretty much the same. So if all of a sudden a bunch of basalt comes up and starts to dissolve, it won't change the composition of the oceans really at all, because it's the same as what was already dissolving on the continents from granite. The point is that ocean chemistry is largely driven by what is being dissolved on the continent. Mm-hmm. So if the rocks that are brought up from the ocean, like basalt, if they have the same isotopic composition as the granite on the continents, that's not really meaningful. But in the case of strontium and neodymium, they both happen to be really different between continental rocks, granite, and oceanic rocks, basalt. And so if a lot of basalt comes up, we should be able to see that in the ocean strontium and neodymium signal.
Interesting. And they're also fairly stable elements. Is that correct?
Yeah. So,
I know I've done barium strontium isotope analysis, and because one tends to get weathered more than the other, and it just that's basically what I was trying to get at. I'm sorry.
Sure. No, exactly. So the point is, like we referenced earlier in this, over 450 whatever million years, a lot of stuff can happen to a rock that'll mess up the chemistry of it and sort of reset what you're trying to actually study. It makes doing forensics harder. That's also an important point. Strontium and neodymium tend to be pretty well preserved in rocks, whereas some other things which might be informative, they're very sensitive to getting messed up, to getting jumbled up over the duration of geologic history. So strontium and neodymium is
their clocks were reset based on burial depth or based on heat or based on
Yeah. The stars almost have to align in order for a chemical signal to be really excellently preserved in a rock. And I'll go out on a limb here and say that, you know what?
First on the Geology Flannelcast.
That's right. In the case of strontium and neodymium, and especially neodymium, neodymium is an amazingly robust signal. I mean, you can measure that in dolomites pretty reliably. No, I mean, yeah,
so dolomites have had a lot of secondary alteration.
Yeah, rocks that are really messed up. Like
I thought you were talking about the '80s rapper. Sorry.
Well, that too. But some rocks are really messed up. To the point where for years people were like, don't even bother measuring stuff in that. And then at some point, someone was like, you know what, I'm going to measure neodymium isotopes in these messed up rocks just cause. And they found that, you know what, it's actually pretty well preserved. So neodymium I have a lot of confidence. And again, I'm biased, but I have a lot of confidence in the preservation of neodymium. Strontium's good too.
But neodymium's interesting. That's it's essentially like a super magnet.
Yeah, that's one of. I have some neodymium magnets. They're pretty badass. Yeah.
Yeah. Like if you had two hockey pucks of neodymium magnets and you stuck your hand between them,
it's like break your fingers.
Your hand would be obliterated. Like that's how strong that magnetism is.
The limestones, for the record, do not behave that way.
No, it'd be much cooler if they did.
Not for you, maybe. Not for me. I gotta work with a lot of them. So,
so all right, let's bring it back to these.
Yeah.
So your findings on your the geochemical stuff you've done.
Sure.
So you said you're testing this hypothesis that these weathered down basalts are affecting the CO2 levels in the atmosphere. So do you have anything to say about that, or do you have any results that you're ready to say things, or some preliminary stuff? Like, so
absolutely. So I'm not the first to look into this in terms of strontium and neodymium. I'm taking a different approach, which I'll describe in a minute. But there's been at least a lot of preliminary evidence with strontium and neodymium isotope measurements that suggest that, yes, something real happening at this time with an increase in basaltic weathering. But the long-standing problem has been that in our geochemical record of paleotemperature during the Ordovician, during this period where there's enhanced basaltic weathering, there's no cooling that's observed. And so we, as a research community, have been trying to reconcile that of like, okay, I mean, this is conceptually, this makes sense. Basaltic weathering, there should be cooling, but that's not what we seem to, what we're observing between these two records. So on the topic of results that I have created during my PhD, the approach that I took is trying to minimize the uncertainty in, I'll say, our age models. So basically, you know, when you measure a rock and you say that rock is 470 million years old, you have to have a pretty, you've got to do a lot of thinking in order to be able to say that a rock is 470 million years old.
Right.
And so in the work that's been done, we've been doing our best the whole time. It's, you know, like we've been talking about, you're limited by the amount of information that's preserved in the rock record. So sometimes we do our best to assign absolute ages to rocks, but it's constantly being improved. And so what I'm trying to do is, part of my approach in this is thinking that, well, maybe we don't see cooling during this time because we don't have enough data points, and two, the data points that we do have are not placed correctly in time. There's a lot of age uncertainty throughout this interval. So I went out to one succession of limestone out in the middle of nowhere, central Nevada. I was like 20 miles from the nearest paved road. My lab mate and I, we rented a Ford F-250, drove out on some crazy, those are the most intense dirt roads I've ever driven on, and some remote canyon, but there's this one hill out there. It's a very special hill, and it exposes limestones through this time interval really nicely. So we went out there, we took a bunch of rock, and we measured strontium, neodymium, and temperature, which comes from oxygen isotopes, which I haven't really talked about, but paleo temperature, all from those rocks at that one location, which has never been done. Usually we're taking pieces from here and there and whatever, and that introduces all kinds of uncertainty. But we went out to one place and tried to pair all these things together so we could really figure out what the heck is going on during this time. And what I think, and this is pending reviewer approval, but what I think is that there's a pretty real signal between the weathering signal, strontium and neodymium, and the temperature signal at this one location. It shows pretty well that, hey, look, there was a change in basaltic weathering. And when you measure temperature at much higher time resolution, you know, more data points, you can see that there is a cooling here. And so I think that's pretty novel and exciting.
Now, as a, you know, novice in this, you said you're measuring stuff in the Appalachian Basin or Appalachian Mountains. But you're measuring stuff in Nevada.
Out Nevada. Yeah, good question.
Yeah.
Let's bring this up.
They're not near each other.
They're not near each other. Here's the reason why, okay? Here's one of the big reasons. One, a lot of this work has been done in the Appalachian Basin, and the Appalachian Basin is in communication, so to speak. There is mixing of seawater during the Ordovician, between the Appalachian Basin and, say, out in Nevada. The reason I went out to Nevada is because there are certain, strontium isotopes. I mentioned that neodymium isotopes are really robust, not likely to be jumbled up over time. Strontium is a little more sensitive, okay? So if you look at any rocks in the Appalachian Basin for strontium, maybe not any, but they're likely to be pretty messed up. So to get a reliable strontium signal in the Appalachian Basin is pretty hard. Other people already have found reliable strontium signals out in Nevada because the rocks out there are just a lot less messed up. And specifically it's not it. The point is you can get strontium out in Nevada. It's harder to get in. So if you want to pair all three, if you want to pair strontium, neodymium, and oxygen, you got to go to Nevada. Yeah, which is still in communication with waters in the Appalachian Basin. So, you know, it does. Yeah, anyway.
So those Nevada rocks just said, a more stable childhood.
A more stable childhood, exactly. That's as far as we can tell, and at this point, I think we can tell pretty well that the records look like they're pretty well preserved. And so it really, in that sense, because I think it also going out there, you expand your geographic domain of study. There are decades of research in the Appalachian Basin, so I think having a data set also from section outside of the Appalachian Basin, but that we think was at least in somewhat mixed with, in communication with the Appalachian Basin, expands our domain of knowledge, I think.
Now, so a lot of this you're saying is from stuff that weathers off the continent into the ocean.
Yeah.
Is there a way to tie, if you have continental rock, I'm just thinking of the Appalachians, where, because this is roughly the same time as like the Catskill Formation or Huntley Mountain. Isn't it
I thought the Catskills Devonian, is it?
Oh shoot, yeah, Devonian. What am I thinking?
Yeah.
I was way off.
Thornburg, we're gonna have to mute you for 5 minutes now.
Jesse. I was when you said, when I was looking at the ages, and it was 465, not 365.
Yeah.
It's like a dummy. But is there
that's
a way,
that's a meaningful difference.
Like if you had the terrestrial rock,
Mm-hmm.
is there a way to tie them together geochemically
Mm-hmm.
to say what's being washed in when? I'm just thinking of a way to like correlate things.
Are you touching on studies of ancient soils, maybe?
Oh, maybe. I don't. Yeah, if you could test isotopes.
Yeah. So I guess to fill anyone in, so I study stuff that was transported to the oceans, but sometimes you can study stuff that was weathered from the continents but didn't quite make it to the ocean, and are preserved on the continents as soils. So
we call them failed ocean sediments.
That's if you told me that's how I would think about it now, my undergrad self would be upset. But so the Ordovician is interesting because this is before the evolution of, or at least the diversification of vascular gland plants. So when you think about whatever weeds are growing out in your yard with roots and stems and leaves and stuff, those there were some of them in the Ordovician, but there weren't a whole lot. Most of what was on the continents were things like mosses, lichens, bryophytes, which maybe encompass those two, things like liverworts. I'm not a paleoplant person, but I do understand that there were not a lot of plants on the continent like we understand plants today. And so that's important for at least the preservation of things like soils, because soil preservation is, and correct me if I'm wrong, Jesse, I'm in your wheelhouse now, but is pretty fundamentally linked to the presence of plants, right?
Some would say, yeah, you need that organic matter to be.
Yeah, it at least helps. It helps a lot.
Yeah, I mean,
so it's not that it wasn't there, but it was just not there in the quantity that it was 100 million years later in, say, the Catskill Formation.
Yeah, think about what a root from a moss would look like.
Yeah, it's next to nothing. I mean, it's next, exactly. So we mostly understand. I have heard, and I haven't looked into this, but Ordovician paleosols are a thing. But the record of Ordovician paleosols is nothing compared to Devonian and earlier paleosols.
So,
well, Jesse, we've seen Ordovician paleosols.
I was going to say we'll bring.
Yeah, is that the Mark Chunk Formation? Am I?
No,
that's not a possibility. Juniata. Oh, I got you. Yeah. All right.
At the top of the Juniata, it turns into like floodplain paleosol stuff.
We'll save this for after the, because there's actually I was just
when it gets
like,
real juicy.
yeah, looking at something really quick. I actually do want to talk to you about something.
Yeah,
Uh-oh.
okay. Yeah, call me on some BS. Yeah, again, not saying not saying they don't exist, but
no. I'm thinking of something maybe we could tie together.
Oh yeah.
But it's technical, and I don't want to get into it.
Sure, yeah.
Well,
So yeah, in terms going back to Jesse's original question of records preserved on the continents, I think the point is those are much harder to study because they're not the preservation is not as extensive. So if you're gonna commit to a PhD doing something, you'll probably go to marine sediments just because that's kind of where most of the stuff is. Sorry to cut you off, Chris.
It's the worst.
No. Once again, Jesse alienates a whole group of people to this podcast. We do not. Jesse's points of view do not represent what the Geology Flannelcast feels. No. So Chris, this seems like really neat work, and it's just really cool. I think kind of to bring it back, kind of like bigger picture view, kind of to kind of take a step back, look at the forest from the trees. Sure. Is you're working on, and we kind of mentioned this in the beginning of the show, but there's just once you get into like what we call like deep time in Earth history, it's really hard to figure out what the climate was. And all of your work is trying to reconstruct from the rocks what the climate of the Earth used to be. And so this is one of the many ways that geologists look at to figure out, how the climate of the Earth has changed over time. And there's a lot of stuff. And this is a very incredibly complicated field. People are getting dissertations over this stuff. This is like people's life's work. It's not this like easy thing to explain. It's very difficult. And I think we did a good job. We tried breaking down these complex topics, but essentially you're just looking at different isotopes of elements and trying to reverse engineer that stuff and figure out how those different isotopes got there into the rocks. That's right. Yeah. By using that, by looking at the we call the geochemistry, we can get a feel. Not like, it's not like perfect. We can't say like, oh, okay, 450 million years ago, we know that the temperature where this rock formed was, X amount of degrees, but we can get a feel for what the trends were. Was it a warming trend? Right. Was it a cooling trend?
Right. And that's based on repeatable experiments.
Yeah. And that's how geologists figure out what the climate was like for this, like the stuff that's, nearly 500 million years ago. When you think about it, 450 million years ago, that's a really, really, really long time ago. And that's when
I started my undergrad.
That's when Steve went through his second junior year of college. No, but this is really cool when you think about it. This is 200 plus million years before the dinosaurs even showed up. 250 million years, whatever. There wasn't even land life. There's no land life. There wasn't even animal. I mean, all the animal life was in the ocean. There was no if you imagine continental landscapes at that time, it was just rocks and covered in moss. Really, maybe some evidence showing just the first hint at land life, or some animals at the very end, creeping up, a little bit. Essentially, though, this is like it's not like what it is today. That's the point I'm trying to make. Think of it as this like barren landscape with just some primitive plants, and that was pretty much it.
This goes a lot of time in my set environments class. I talk about this where I talk about like river systems, and I'm like, the way you picture rivers today is not how you can picture it then.
Yeah.
That's right. That's right.
Landscape looks different.
There was nothing to stabilize. Yeah.
I mean, it's more like a Martian landscape than anything else.
Even when I do like my intro classes or something, I'm like, all right, we'll talk about dinosaurs, blah, blah, whatever. Dinosaurs, whatever. But at the same time, I'm like, picture all the dinosaurs in your head. Now, don't picture any grass. Because grass isn't evolved yet.
Yeah, there was no such thing. Yeah,
it's like people.
It's crazy to think about. Yeah. Even for us who we maybe have known this for a long time, but still, when I think about it, it's like, oh man, that is weird.
Yeah, like the flowers that only start evolving then.
Yeah.
Yeah, there were no flowers. Yeah.
We're more closely related to the Tyrannosaurus Rex than Tyrannosaurus Rex is Triceratops.
Yep.
In time.
Wow.
Stegosaurus.
Triceratops.
I thought it was Triceratops. Anyway,
We're
what I'm saying is,
experts here on the show.
Yeah.
we need Dr. Ray in here.
But you talk about dinosaurs, they spanned 200 million years, but they died off 65 million years ago. So you take some of the earlier dinosaurs, and they were.
It's Stegosaurus too. Sorry, just looked it up.
Thank you.
Yeah.
You said you were very convincing. I believed you.
You say it with confidence, people believe you. Which is
The motto of our podcast.
which is the antithesis of everything we said about science. But so. But it's mind blowing to put your mind in that kind of perspective. Like, this dinosaur to this dinosaur was nowhere near as closely related as that dinosaur to us.
Yeah.
In terms of time,
Deep time, baby. It'll mess with your head,
right?
But no, that was awesome. I think that was. I learned a lot from this conversation. This Chris, you're doing some really cool work, man. Stick with it. Sounds like you'll be graduating in sooner than you realize, and it'll sneak up on you the next. Oh my god, I gotta apply for a job. What am I going to do? And
the next 2 to 10 years, and then who knows?
Hopefully this COVID thing blows over and.
We'll see.
But yeah, man, thanks so much for coming on the podcast. This was really, really neat conversation. I love talking about this stuff, especially for things like such a topical conversation like climate change, but going back 450 million years ago.
Yeah, exactly.
And we have a global cooling period of 40 million years, which is absurd. It's crazy how long that
fairly long time.
Yeah, that's a really long time.
Sounds like a long time.
Really interesting stuff, man. Keep up the good work, man. I'm really excited to see your final results to come out of this project.
Yeah,
and,
this is great.
Keep us posted when you guys.
Yeah, keep us posted. We'll post links to papers and whatnot, and
absolutely,
talks or whatever.
Just let me write this stuff up first, and I'll let you guys know.
That's where the fun begins, baby.
If you want us to just post results, we'll do that now.
Let me do that.
There's no peer review process on it.
When the
premier Geology podcast approves of this, and
let us know when your dissertation defenses, and we'll come heckle your advisor.
Good. Yeah, I'll just be self-publishing monographs from here on out. So
awesome,
nice.
Man.
Hey, thank you guys so much. This was really fun.
Yeah.
It was, you guys had a lot of really good questions, and I appreciate that.
Awesome. Thanks, man.
Cool.
All right, cool. So let's wrap things up here. Don't forget to check out the formatting formula. They'll help you out with any type of formatting needs you have for Microsoft Word. Formattingformula.com or youtube.com/C/formatting formula. Check us out on Facebook at Geology Flannelcast, facebook.com/Geology Flannelcast, or on Twitter at GeoFlannelcast. And don't forget to become, if you really like the podcast and want to try to help us out financially, you can hit us up on Patreon at patreon.com/Geology Flannelcast. Real quick note, and I don't know why I didn't realize this, but the last couple of weeks been saying there's no diamond membership level. There is. I made up a diamond membership level. Totally forgot about it.
I'm glad we're mentioning this an hour and 45 minutes into our podcast.
So if you managed to hang out this long,
you could become the first.
Yeah.
I don't have any diamond.
I will. Yeah. If you're listening to this on your podcast choice program of choice, we are on YouTube too. If you ever want.
Oh yeah, I always forget to say the YouTube. Yeah. You can see our beautiful faces and our beautiful guest face, Chris.
Last week, we did a short episode where we did it live on YouTube. We'll probably do that a little more frequently. We'll throw a few more live episodes out there. I assume publicly, or maybe we'll make that a Patreon only. I don't know. Who knows?
Yeah, we'll figure it out.
We'll see how it goes.
Either
We'll
way.
see. Yeah. But hey, it also every once in a while we do an episode where we just answer listener questions. I've been getting a bunch of listener questions coming in just this week. If I didn't get back to you yet, I will get back to you very shortly. Sorry, I've been kind of busy this week. But if you have
That's unacceptable, Seminac.
this is what I have to deal with week in and week out. Peterson, you could always check up on the stuff too.
I forgot. I lost my username and password or something.
Okay. No, but I thanks for the people that have been emailing us some questions. There have been some really great geology questions coming in. Email us some geology questions. We'll play Stump the Geologist in the near future. So you can do that. Either email us at questions@geologyflannelcast.com, or you can just go to geologyflannelcast.com, our website, and you can see listener questions or whatever. Click on that link, and there's a form you can fill out, and you can send it that way as well. So I think that's it. Just remember, if you're a Patreon, you can come on too and heckle Jesse. It doesn't just have to be his brother. We don't really have that officially set up yet.
No, we don't have any nepotism here.
If you email me at chris@geologyflannelcast.com and you have a good enough reason to heckle Jesse or Steve, Thornburg's not out of this, right?
Wait, what?
You become a diamond member.
Peterson's
You can come on and heckle us all.
Yeah.
If you're a diamond member, you can come on.
Yeah.
You can have 5 minutes of the show.
We'll give you Chris Conwell's email address. You can heckle him.
Yeah, you can have it.
I'll give you his cell phone number. No, I'm joking. No. If you give me a good enough reason to come on the show and heckle one of us, we'll think about it.
Yes, absolutely. I will take it.
Giant asterisk right there. All right, everyone. Okay, I think that's it for the day. Thank you so much, everyone, for listening all the way through. We love our fans. You guys are awesome. And thanks for listening. We will catch you guys next week. Bye.
Thanks.
Bye.